You know, as an American, this isn't exactly what I think of when I hear the word football. But with over 4 billion fans across the globe, as opposed to 400 million mainly in the US, soccer, or football, is the biggest sport in the world. And it has been for a while. Football is over 3,000 years old. People have been playing games where they kick things for millennia. The Mayans and Aztec civilizations played a game as early as 1400 BCE. Sushu from the Han Dynasty of China is recognized as the earliest form of soccer, and that dates back to 200 BCE. But the first modern football club started in the UK around 1802. And the first international tournament was in 1930, almost 100 years ago. Back then, only 13 countries participated. Now, over 200 countries have a national football team, or soccer team, whatever. A lot of things have changed since the first international tournament, and the biggest change is the football itself. Back in the 30s, this ball was made out of a rubber bladder covered in leather strips. This kind of ball was great for kicking, but terrible for heading. The stitching was super heavy, and these balls weren't exactly waterproof, so when they got wet, they got even heavier. They were also prone to deflating, so sometimes they had to be reinflated during the game, which was a real hassle. Today, official tournament balls are a little different. This ball is made out of polyurethane and only has 4 thermally bonded panels. And most importantly, it's completely waterproof, with some texture added to help it grip on the ground when the field is either dry or wet. The ball part of football has changed a lot, and so have the players, you know, the ones who play with their feet. With a better understanding of fitness programs, dietary considerations, and other advances, athletes have gotten faster and more agile through the years. But when the equipment has evolved as well, let's think about that. What does it mean when you make changes to the most important piece of equipment in the game? If you kick with the same power and technique, just with different equipment, what will happen? With SOLIDWORKS simulation, we can virtually investigate these types of questions without having to set foot on the pitch. Wait, did I get that right? It's called a pitch, right? The modern polyurethane ball and the dry, older leather ball share similar stiffness characteristics. But wet leather is a fundamentally different material. When leather absorbs water, it becomes dramatically softer, up to 5 times less stiff than when dry. The measure I care about is simple. How much of the energy from the kick does the ball actually return? A stiff ball gives it back. A soft one absorbs it. This is exactly where SOLIDWORKS simulation shines. I'll set up a nonlinear dynamic analysis. The ball is modeled as a pressurized shell. The plate as a rigid body dropped from 1 meter. An impact velocity of 4.43 meters per second. 3 balls, 3 materials, same setup. Here are the results. The modern ball compresses at the contact zone. Stress concentrates cleanly at impact and distributes predictably through the shell. Controlled, uniform, exactly what you'd expect from a well-engineered ball. The dry leather ball from the 1930s tells a similar story. It holds its stiffness under load, and the stress distribution is comparable. Structurally, it holds up. But everything changes once the leather gets wet. Same geometry, same drop. The waterlogged shell yields far more. The contact zone spreads, and the stress profile tells a very different story. 3 balls, 3 very different structural responses to the same impact. The modern ball and dry leather ball stabilize quickly. The wet ball takes far longer to recover. The softened shell stores less energy and dissipates more of it. The nonlinear dynamic analysis with SOLIDWORKS gave really good insights. And now I want to investigate even more. As the complexity of the study increases, I need to leverage more compute power. The 3D Experience platform gives me just this: high-powered cloud computing, the best meshing techniques available, paired with extremely powerful, nonlinear explicit solvers from Abacus. I am stepping up from design analysis to full product verification. A 1930s leather ball soaked in rain could weigh nearly 50% more than when dry, and perform dramatically worse. The results show how much energy from the kick is absorbed into the ball, making gameplay much slower and more difficult for players of the past. They were not just kicking a heavy ball, they were kicking a structurally compromised one. Design solved that, and simulation at every level is how engineering is done with confidence. Seeing the evolution from early leather balls used in the 1930 International Football Tournament to today's advanced composite designs shows how improvements in material science, structural integrity, and moisture resistance didn't just increase the speed and action of the game, but also improved consistency, predictability, and player safety. And this is from just a century of improvement. What do you think will happen to football in the next 100 years? I can't wait to find out, and maybe use simulation to test that out too.